Hello my all dear students, very most welcome to all of you in this our online lecture series. Dear students, in previous lecture we have discussed the next heat transfer method, which was convection. The all examples we have told you, all examples of this topic, and we have told you convection are two types, natural convection and forced convection, and example of both natural and forced convection we have discussed in my previous lecture. Today we are going to next and last heat transfer method, which is radiation. Dear students, as you know, we have told you in case of conduction, when we supplied heat energy to this end, then whole rod will warms after some time. Here conduction of heat, or so we can say, here this flow of heat is known as conduction, we can say. In this case, here heat going from this into this in, or we can say adjacent part, heat is flowing from one part to adjacent part or successive part of this body. So in case of fluid also, we have told you the next method, which was convection. In convection we have told you this method is applicable only in fluid. So we have told you two types of convection, natural and next is forced convection. Now here dear students, in radiation it is third heat transfer method. In radiation we do not require any medium. Here medium is not required or need medium. We do not need any medium to flow or transfer of heat. In case of radiation, here we want to say we have no need to transfer heat from system to surrounding, we can say, or also from one place to another place also, we can say. In this method we have no need to transfer heat, no need of medium. We have no need of medium. Here also we have no need of medium to transfer heat from one place to another place. Dear students, this is next and last method of transfer of heat. So here how energy goes from one place to another place, or heat energy transfer from any system to surrounding also, here we can imagine. So here if we shall talk about this question, then answer of this question is, dear students, here this heat energy flows or transfer with the help of electromagnetic wave. Now here we want to introduce what is electromagnetic wave. Dear students, as from its name it is clear, it consists by electric and magnetic field. Electromagnetic wave have electric and magnetic field both, and magnetic field. Electric and magnetic field both are oscillates in this wave, both are oscillates, and remember please, this electric and magnetic field oscillates in perpendicular order. Here if we are considering a coordinate axis, then we can see here, if electric field oscillating into y direction, then magnetic field oscillates into z direction when this electromagnetic wave propagating along x direction. When wave is going into x direction, then electric field vibrates, oscillates into y direction, and magnetic field oscillates into z direction. We can consider it is a 3D shape. It will 3D will be in 3D, so we can feel it. And dear students, as we have told you here, heat energy goes from one system to another, or system to surrounding, we can choose here. This method is known as we have told you radiation. And dear students, uh, now uh, this supplied heat energy, which is going from system to surrounding with the help of electromagnetic wave, energy going from here we can say system to surrounding, or one place to another place, from system to surrounding, or also dear students we can say from one system to another system also, we can say from system to surrounding by system to surrounding by electromagnetic wave. As we have told you, what is electromagnetic wave? Surrounding by electromagnetic wave is known as radiant energy. Remember please, this heat energy which is going from system to surrounding, or one system to another system by electromagnetic wave, then it is known as radiant energy. Radiant energy. As we have told you, we have no need to transfer heat in this method. Here heat is going from system to surrounding, or one system to another system, or one body to another body by electromagnetic wave. It is known as radiant energy. So dear students, as we have told you, in electromagnetic wave, it is consist of electric and magnetic field. And what is the speed of this electromagnetic wave? This electromagnetic wave have speed in vacuum 3 into 10 power 8 meter per second. As we know, it is also speed of light in vacuum. So dear students, we have told you this radiant energy. Now I hope this concept radiation and radiant energy has been clear to all of you. Now this radiant energy, dear students, which we have told you, energy going or energy emitted by electromagnetic wave from any body or from any system, it is known as radiant energy. When this, and also as a knowledge we can see, or also we can feel it, all bodies here may be solid, liquid, gas. Dear students, all bodies emits energy or radiates energy also, we can say here. Radiates also we can write here, radiates energy by virtue of its temperature, by virtue of its temperature. It is very most important topic, important concept. All bodies, solid, liquid, gas, radiates energy by virtue of its temperature. Dear students, if temperature of any body is rises or corresponding to any object, then as we have told you, heat energy goes from higher temperature to lower temperature, or due to temperature difference. So either it is solid or liquid or gas, all these bodies have some radiate some energy, either it is solid or it is liquid or it is gas, maybe solid, liquid, gases. but all bodies radiates energy due to its temperature difference or by virtue of its temperature also we can see here. Dear students, when any object at any particular temperature radiates energy or emits energy, we can say it is known as thermal radiation. The electromagnetic radiation we can say emitted by a body by virtue of its temperature, like radiation by a red hot iron or light from filament lamp, is called thermal radiation. Dear students, you have felt if any hot rod, it is any hot rod is placed here, and when if you will come very close to this rod and this rod is very hot, then you feel warmth or you feel some hotness to close very close to this rod. When you will come very close to this rod and this rod is very hot, then you will feel some warmth. So dear students, as we have told you, all bodies radiates energy, we can say heat energy. So here in example we can say, in example we can say here we have told you, if we have taken here any hot rod and if we shall come or you will come very close to this rod, this is hot rod, and you will feel warmth after some time, or quickly you will feel hotness. So here we have told you why you feel hotness or warmth. So we have told you answer of this question: all bodies radiates energy by virtue of its temperature. So dear students, if any hot rod radiates energy, then it is known as thermal radiation. Here radiation by electromagnetic wave also we can say radiation by electromagnetic wave, radiation by electromagnetic wave is known as thermal radiation. The place of thermal radiation, as we have told you, very close to this hot rod, or we can choose any other substance also, liquid we can choose here also, hot water also we can choose here. Then we shall feel also in case of liquid some hotness very close to this hot water. So radiation by electromagnetic wave is known as thermal radiation. Now dear students, here thermal radiation, definition of thermal radiation we have seen. When this thermal radiation, or we can say this radiation which are occurring by electromagnetic wave, when it is incident upon any other objects, then also some part of this radiation, or we can say some part of this thermal radiation will absorb, and some part may be reflect. So absorption or reflection is depend upon the color of body here. Now the next important concept here we want to see here, if thermal radiation, if thermal radiation falls on other bodies, falls on other bodies, it is partly it is partly reflected and partly absorbed partly absorbed. So dear students, this reflection or absorption property of any substance, of any material, is depend upon the color of substance. Here we want to told you the absorption the absorption here we can write absorption by radiation depends upon the color of body. Now here we want to see what is best color to absorb more heat from any system or from any surrounding. So dear students, here if we shall talk about of this question, then we shall see the black body absorbs all radiant energy compared to lighter object, we can say are white bodies also we can say compared to white bodies. Dear students, so due to this reason, always we keep black dress or cloth also we can say in cold day. And dear students, due to this reason we keep white dress or white cloth in summer day. So we keep white cloth in summer day. Also many examples in your everyday life is present on the basis of this concept. Dear students, always we keep black bottom of cooking pots. Due to this black color, the absorption or also we can say emission, absorption or emission, because all body radiates energy, we have told you. So emission also we can say. Black body we have told you absorbs more energy, or we can say all types of wavelength, so it emits also more energy, and all types of wavelength also we can say. So always we keep black bottom of cooking pots. Now dear students, next another example of this concept, we can say uh, thermal bottle. Thermal bottle. Dear students, in thermal bottle we have two walls, and this walls, these both walls are silver coated, both walls. One is here, both wall means we can say one is inner and one is outer walls. So inner walls reflect energy from these walls, reflect heat energy from contents which are filled into this thermal bottle. If we have kept a hot water in thermal bottle, then inner wall reflects heat energy from the wall. Hence in results we can say from the inner walls, or we can say heat energy from the content cannot go from the content to the surrounding, because this heat energy reflects from the silver coated glass inner walls which are silver coated glass. So this heat energy reflect back or returns to the content from this inner walls, and from the outer walls no energy will go, no heat energy will go from surrounding to the inner walls or content. Dear students, here as we have told you, two walls, inner and outer. Outer walls prevent the heat energy goes from the surrounding to the system, and inner walls prevent the heat energy cannot go from inner or system to surrounding. We can say in simple language, inner walls prevents the heat energy supplies from system to surrounding, and outer walls from surrounding to system. So temperature remains constant. If we have chosen here, we have taken here hot water, so after a very long time its temperature is constant. So, and also here we keep one next another concept into this example. We keep vacuum between two walls. Two walls means inner and outer. Due to this vacuum, no heat energy will move from system to walls of container also, or inner walls, by conduction method. So dear students, here we keep vacuum between two walls. This due to this process, thermal bottle, in thermal water, when we keep any hot water or any hot matter, so temperature of this matter is constant after long time. So dear students, today we are going to stop here. We have discussed the all concept about of radiation. So we shall discuss the next important topic black body radiation in the next topic.